Welcome to the Demography Today lecture series, sponsored by the BBVA Foundation and co-organized by the Spanish National Research Council and the LOMPOP Horizon 2020 project. We have the pleasure today to have here Joel Cohen. He's the Abbey Rockefeller Mauzé Professor of Populations at the Rockefeller University and Columbia University in New York. He studies populations, ecosystems, and environments using mathematical, statistical, and computational tools. His work focuses on human health, other species humans interact with, and the human environment. Recent examples include food webs, insect-borne infections, tornadoes, and human population dynamics. Cohen has used modeling to make projections about asbestos-related injuries, future population growth, international migration, and lifespan. He has published 14 books, including How Many People Can Earth Support, and a book of scientific and mathematical jokes, and more than 430 scientific papers and chapters. He has written for the New York Times, Wall Street Journal, Project Syndicate, Discover, Scientific American, and New York Review of Books. His video, Introduction to Demography, an Introduction to Demography and Population Study through an Examination of the World Population, that is in YouTube, has been viewed by more than 200,000 times. He is member of the US National Academy of Science, the American Academy of Arts and Science, and the American Philosophical Society. Cohen earned 2 doctorates at Harvard University, one in applied mathematics and another in population science and tropical public health. And for us, it's a real pleasure and honor to have you here in our lecture series. As usual, we allow the speakers between 45 to 1 hour talk, and then we open the floor for some questions.
My title is Hunger Does Not Pay, and I will try to explain what that means by the end of the talk. If any of you is a lawyer interested in intellectual property rights, this slide is for you. I will be using copyrighted material under the doctrine of fair use. If there's a problem, come see me after the talk, please. This is the whole story I want to tell you. Food is superabundant, but 1 person in 9 on this planet is chronically hungry. Hungry in the morning, hungry all day long, hungry at night. Malthus's theory of why people are hungry is wrong. There are multiple causes for chronic hunger, and many consequences, both for individuals at the micro level and for societies at the macro level. There is a great opportunity for investment that would make money if people invested in ending hunger. But that's not the only argument for ending hunger, because hunger degrades people. So that's the story I want to tell, and I'm going to go through each of these points. First, food is superabundant. This is a headline from Reuters Business News. I'm going to be talking about statistics largely from 2017 and 2018 because the 2017 to 2018 crop year is finished. So we know what was grown and we know what happened to the food. For the 2018 to 19 year, we don't have the statistics yet, so I'm not going to be talking about the current year. The headline says, grains piled on runways, parking lots, fields amid global glut, and they give a caption which you may not be able to read. A mountain of grain sits in a storage pile as Midwestern grain farmers and merchants struggle to find storage space after 3 years of record harvests. Near Minburn, Iowa in the United States, March 11, 2017. Under this caption, there were then 4 photographs. I will show you those photographs. There are no grain silos available because they're all full. So they are dumping it in a bin on the ground. The silos are full. There's more food than can be stored. A later story says, world stockpiles of corn and wheat are at record highs. Farmers face similar problems like those in the US across the globe. World stockpiles of corn and wheat are at record highs. From Iowa to China, years of bumper crops and low prices is an indicator of abundance, not scarcity, have overwhelmed storage capacity for basic foodstuffs. Global stocks of corn, wheat, rice, and soybeans will hit a record, and we'll get into that, 3rd straight year of historically high surplus, according to the US Department of Agriculture. Enough surplus in storage to feed China for a year. Never has the world produced so much more food than can be consumed in one season. And in September, global grains glut is now in its 4th year, supplies bloated by favorable weather, increasingly high-tech farm practices, and tougher plant breeds. This is the most recent FAO World Food Situation, last month, February 2019. And the cereal grains, so the gray columns are what's in storage. We are here. This is forecast, means we don't know what it'll be. But we do know this is what's in storage. The yellow line is actual use. The orange line is production. And basically, it's 2,600 million tons. That's 2.6 billion metric tons of grain. The world stocks to use, stocks meaning what's in storage, use is how much you're consuming, for that crop year was 30.8%, the highest in the last 18 years. Now, how much does it take to feed me for a year? Do you happen to know? Well, I need 2,000 kilocalories. Please follow this calculation. I need 2,000 kilocalories per day. That's a population average, a population of me's, okay, or you. 2,000 kilocalories. 1 gram of carbohydrate from grain gives you 4 kilocalories. I need 2,000. 1 gram gives me 4. So if I divide 2,000 by 4, I get 500 grams. That's the amount of carbohydrate I need to feed me for a day. 500 grams times 4 kilocalories per gram gives me 2,000, okay? 500 grams. Let's say there are 400 days in a year. I know it's less, but let's allow for wastage. 400 days in a year. I need half a kilogram each day. 400 days, so how many kilograms do I need in a year? 1/2 times 400. It's 200 kilograms. 200 kilograms is 1/5 of a ton. So 1 ton of grain can feed 5 people like me for 1 year. Okay? If instead of 2,000, we set the average at 2,500 kilocalories per person per day, if you're really big, okay? You need more calories. 2,000, so some calculations are bigger, 2,500. All that means is 1 ton feeds 4 people for a year instead of 5. Okay? So 1 metric ton of carbohydrates supplies enough to feed the energy, not the minerals, not the vitamins, not the trace metals, that's another thing. But the energy, the basic core energy, feeds 4 to 5 people for a year. So 200 kilograms of rice gives you 2,000 kilocalories per day for a year. Wheat, corn, oatmeal, it's all around 2,000. So if we grow 2.6 billion tons of cereal, we multiply this by 4, and we get 10 billion. We multiply it by 5, we get 13 billion. Okay? Very elementary arithmetic. So we got a lot of food, enough to feed far more people than we have. Does anybody know how many people we have? It's 7.6 billion. Okay? So everybody should be eating well. Now, what happens? Chronic hunger is widespread. There are 2 different kinds of hunger. There's famine, which is an acute shortage of food that goes away after a little while. And there's chronic undernutrition over a long period of time. Famine makes news. Chronic hunger rarely makes news. Childhood stunting, and I'm going to tell you later what stunting means, measures chronic hunger. Childhood wasting, which I will define later, measures acute hunger. Childhood underweight is a mixture of those and is not informative. Let me show you some people suffering from chronic and acute hunger in famine. These pictures are hard to take, so if you want to shut your eyes, shut your eyes. This is a little boy in Hodeida, Yemen. I want to point out some things about this picture. Look at his arm. There is no subcutaneous fat. So he looks like the arm of an old man. There's no fat under here. Look at his hair. He comes from an Arab country. What color are people's hair? What's the color of people's hair there? Black. So why is his hair red? Because he doesn't have the protein to make his hair black. That's a sign of chronic undernutrition. Hair grows about a little over 1 centimeter a month. So this child has been undernourished for at least 6 months because it's about 6 centimeters long. Another feature here is that the child is desperate to get something in his mouth. And the only thing that's available to get in his mouth is his own arm. That's why his arm is in his mouth. And the last observation is the child lacks the energy to get this fly off his arm. So this is a child at the edge of survival. This is another girl, reddish hair again, and she died shortly after this photo was taken. This girl died the day after the photo was taken. again in Yemen. This boy has not only severe malnutrition, he has cerebral palsy. But look at his mother. She's extremely undernourished. And this is not a recent phenomenon. I saved this picture from the New York Times in 1993. That's 26 years ago. Children have been starving in war-torn areas for a long time. This is a little girl, and there's a vulture waiting for a meal. To summarize about famines, government policies have killed wars, drought, and flooding altogether have killed about 35 million people in famine since 1950. The biggest number of deaths was in China due to Mao's Great Leap Forward. And the numbers range from 18 to 40 million. The estimate given here is 25 million. I don't know. Other conflicts are in Congo, Iraq, Ethiopia, drought, maybe 2 million, and other causes like flooding in Bangladesh. The case I want to make is that these deaths from acute famine are very small compared to the damage by chronic hunger. Chronic undernutrition rarely makes news. I will show you some pictures of children affected by chronic undernutrition. Chronic hunger, what is it? It's the inability of persons to consume enough food sufficient to meet dietary energy requirements. There are, in fact, over 200 definitions of food security by 1992, and there have been many more since then. So there are lots of different ways to measure when a country has chronic hunger, when a person has chronic hunger. Here are some different approaches to food insecurity. One is you look at what number or percent of people are living on less than $1.08 a day at 1993 purchasing power parity prices. This is World Bank definition. Another way is what's the number or percent of people with food intake below the minimum level of dietary energy requirements, below 2,000 kilocalories, for example. So one way is by income, a second way is by food consumption. A third, and that's based on national statistics. A third way is based on sample surveys where you go ask people, adults, were there days when you could not eat or people in your household couldn't eat? Yesterday, last week, in the last month, in the last year. That's asking people. They don't ask children. They ask adults. And another approach is low-income food deficit countries, meaning FAO does a balance of the food that comes into a country by import, the food that's grown in the country, and the need for food in that country. If the need for food is greater than what comes in and what they grow, it's a food deficit country. And from that, they infer that there's chronic hunger. And a new measure that was just introduced, absolute poverty, says when you're really low income, you don't get to choose what you do with your money. You buy food. But which food you buy is a choice. And absolute poverty means you don't have enough food to meet the minimum. So measuring chronic hunger is difficult. And here's an example from a paper in Science of people who are estimated to be undernourished by the FAO and food insecure by the USDA. So you notice that the world estimate for the FAO is 0.02 billion, which is bigger than this one, but in sub-Saharan Africa, 265 million is less than that by quite a large margin. I'm just trying to show you that these measures don't always agree and may not be the most reliable way to measure chronic undernutrition. However you measure it, fortunately, the numbers and percent of people who were chronically undernourished has been falling until recently. So in 1990, 1 billion by the measure of the FAO, 800 million in 2014, 795, under 800 million. 19% to 11%. In the developing countries, a bigger drop. This is where the hungry people are in developing countries. 23% to 13%, that's a big drop. But in the last 3 years, the percentage of people chronically undernourished has been rising, and the number has been rising. And now it's about 800 million. A more reliable way to measure chronic undernutrition is to go look at individual children. We're not talking about the adults now, just children. And the 3 measures which I'm going to talk about are stunting, wasting, and underweight, plus a 4th one, the mid-upper arm circumference. So I won't do this on anybody, but you find out where the tip of the shoulder is. You can feel a bone there. You feel your elbow, and then you take a tape measure, and you measure the distance, and halfway in the middle is the mid-upper arm. Then you take another tape, and you put it around, and you read off what is the circumference around the arm. This is very easy. You don't need to be a doctor to do this accurately. You can train anybody, any health worker, to do this accurately, okay? So it's called the mid-upper arm circumference, and it shows acute wasting. It's a short-term measure, not a long-term. It also happens to be a very good predictor of death in the child, whether the child will die. And I'll give you the numbers right here. If the child's height, if the child is short for his age, excuse me with this, if the child is short for age, unusually short at the short end of the distribution, the child is said to be stunted. If the child is low weight for height, the child is said to be wasted. Stunting measures chronic undernutrition, wasting measures acute. Equivalently, for measuring wastage, if the circumference is less than 115 millimeters, the child has somewhere between 5 and 10 times the chance of dying in the next couple of weeks of a normal child. But you should ask, what is this reference population? And that is based on a study done by the World Health Organization. For 6 years, they followed several thousand children, 8,440 children, in Davis, California, Oman, Norway, Brazil, Ghana, and India, all over the world. They measured growth meaning the age, how long the child is or how high, depending on whether it can stand, and weight. For every week, for 1 year, then monthly, then every other month, up to age 5. In mothers who were affluent, healthy, non-smoking, well-nourished, breastfed their children from middle-class backgrounds. The interesting thing is that up to age 5, children from all these different cultures have similar growth schedules. After that, there's some differentiation, but very similar, so you can use one set of norms for all the children in the world under age 5. And here's an example. So if you take the median height on this axis is right here in the center of the dot. And that's the commonest height among well-nourished. This is a well-nourished distribution. It's called a bell-shaped curve or normal distribution. And in India, when they did this with 50,000 boys and girls, the median was 1.83 standard deviations below the median of the well-fed children. And from 2 over to the left, these are stunted children in India. So in a healthy population, very few children are stunted, just this many. In India, a huge fraction of all children are stunted. It's not obvious when a child is stunted. Look at these 2 girls. Would you say that they're stunted? I mean, they look the same, right? Except one of them is 2 years and 2 months old, and the other one is 4 years and 4 months old. Now, this is the median growth curve, the green line, and this 2-year-old is very close to the peak of that normal distribution. The 4-year-old is 1, 2, 3, maybe 4 standard deviations too short for her age. The author of this article did not tell us which one is which. And my guess, just a guess, so you can have your own guess and your guess is as good as mine. My guess is that it's this one because of the red coloring in her hair. That's a sign of chronic undernutrition. But just looking at her, she has a prettier dress, she looks more confident, but she's got red hair and she shouldn't have red hair. In Guatemala, nearly half of children under 5 years old were stunted in 2017. So this is children born and raised in Guatemala who are 9 years old, and that's the median where they should be, and this is their height. Please notice every one of the girls is shorter than every one of the boys. The girls are last in line for protein and high-quality food. They come last, and they are the most stunted. Here we are. These are children who were born to parents of Mayan origin, same as these people, but in the United States, and they ate US food. And this girl is taller than the norm, which is the same norm here, and the rest of them are pretty close to the norm. So it's not a genetic thing that Mayans are short, it's just that they haven't been fed in Guatemala. In the last year for which we have credible data, 151 million children under 5 were stunted. The fraction stunted fell from almost 30% in 2005 to 22%. Still, in 2017, still nearly 1 in 4. So almost 1 in 4 of all our children on the whole planet are stunted from chronic hunger. And where are they? Most of them are in South Asia. Very few in East Asia. China has managed to feed its surviving people. The next concentration is the hunger belt across Africa, Western Africa and East Africa. They're smaller numbers in the New World. The global trend is for the numbers of stunted to come down and for the percentage of children under 5 stunted to come down. And that's the trend you see in Asia, thanks to the progress largely in China, much more so than in India. Dramatic decline from 48% to 25%. in the space of less than 25 years. That's amazing achievement. Latin America and the Caribbean was lower to begin with, and it's come down. The problem is Africa, where while the percentage comes down, the population is growing so rapidly that the absolute number of stunted children is continuing to increase. Malthus's theory of hunger was wrong. Malthus theorized that populations grow exponentially and food production grows linearly. So eventually population growth has to outstrip food production. What we see here is that there's a lot more food that's not going to feed people. That's not consistent with his model. What we see is that the rich countries where food is abundant have the lowest population growth rates, while Africa and South Asia with the highest population growth rates are the poorest countries with the least food. That's also not consistent. So this theory fails to explain today's widespread chronic hunger. People grow more than enough cereals to provide food energy for everybody. And the Green Revolution, which has increased food production, began just as the fall in population growth began in the 1960s. World population growth rates increased up to around 1965 and then have fallen by half in the last half century. Many people don't know that the rate of increase of population now is half of what it was in 1960. So there are many reasons for chronic hunger. And you can think of this as a pyramid with the basic reasons, intermediate reasons, and immediate reasons, or you can think of it as a circle. So this is the World Health Organization. Chronic hunger is affected by the society and culture, availability of education, the politics, not just political economy, but does the government care about whether its people are starving? Some governments don't care. It's affected by agriculture and food systems, water, sanitation and environment, health and healthcare. Why sanitation? If a child is chronically infected because its water supply has feces in it or human waste, it loses through diarrhea what it gets in the way of intake. And bouts of diarrhea are a precursor to chronic undernutrition and death. So water, sanitation, and environment are very important environmental factors in undernutrition. Within the community and nation is the household. And the mother may not know how to take care of a baby if she hasn't had any education and nobody tells her. You're not born knowing how to do that. You have to learn. There may not be adequate breastfeeding. The father may take all of the protein. The usual thing is if an egg comes into a house, the man gets it. If there are 2 eggs, the woman gets it. If there are 3 eggs, the man, woman, and boy gets it. And it's only if there are 4 eggs does the baby girl get it. So the household structure makes a huge difference. And within that is the characteristics of the child. So at the community level, there's politics, there's agriculture, there's water and sanitation, health and healthcare, society and culture. What's missing from the WHO list is any discussion of the quality of governance and the quality of leadership to deal with this. At the household context, there's the home, the quality of foods, food and water safety, infection, the mother, adequate care, breastfeeding, other feeding. But again, there's no discussion of how many children are there in the household, how many siblings are competing for the food. So the WHO has stepped away from its responsibility to lead in dealing with governance and in dealing with rapid population growth and high fertility. They're just not mentioned here, and I think they should be mentioned. The characteristic of the child itself that's the best predictor of stunting is having been born at full term, that means after 9 months of gestation, and being small, smaller than you should be at that age. That's the best predictor of stunting. So a lot of stunting begins before the child is born in terms of gestation within the mother, because a lot of mothers are stunted and have inadequate nutrition and inadequate care during their gestation. The more educated a mother is, the lower the rate of stunting. Other contributors are the food supply, government policies, the environment, and lack of money, and I want to talk about lack of money. These are the factors that contribute to stunting. Here are different countries. This axis is the percent stunted. The blue circles are the fraction of children who are stunted in the top 20% of the population by income. The top quintile means the top 20%. So in Guatemala, the top 20%, maybe 15% of the children are stunted, but in the bottom 20% by income, 70 to 80% of the children were stunted when this study was made in 1998. Now it's down to about half, which is progress, but not great. And what you see is that there's always a big gap between the poorest fifth and the highest fifth. It's not genetics, it's access to cash to buy food. Hungry people are economically invisible in grain markets. Lack of effective demand, which means demand supported by customers' orders and capacity to pay for sufficient food, contributes materially to widespread chronic undernutrition of children and adults. The 800 million chronically undernourished people today exercise less effective demand. I can want food, but if I don't have money, I can't exercise effective demand. I can't go to the counter and pay for it. Exercise less demand than those who demand meat, biofuels, and other non-food uses of grain. So you should be asking yourself, we grow 2.6 billion metric tons of grain, where does it go? 22% of the grain goes into machines. It goes into gasoline additives that are required by law in the United States. Corn ethanol must be 10% of what goes into a gas tank. So it takes corn, converts it to alcohol, goes into my car. If you have a sustainable cartridge for the ink in your printer made from soybeans, the soybeans are going to make ink for printer cartridges. If you have a starched shirt, starch, what is starch? It's carbohydrate from plants. All starching comes from that. Many plastics come from plants. There are many, many applications. So 22% of the grain goes into machines. 35% of the grain, more than a third, goes into the mouths of animals that are being raised by rich people so that they can have meat. Chickens, pigs, cattle, all the domestic animals. And the fraction that goes into human mouths is 43%, less than half. So only 1.1 billion metric tons go into people, and the rest go into other uses. And that is driven by economics. because the people who want sustainable cartridges and gasoline for their cars and cheap chicken meat can afford to pay for the grain. And the hungry people are not in the market because they don't have any money. Okay, what about the consequences? Well, they're big. They're big for individuals and they're big for the society. And here's again the WHO framework. There are short-term consequences and long-term consequences. The short-term ones are mortality increases, we've already said that, sickness increases, the working of the brain goes down, motor skills go down, language development goes down, health expenditures go up, and you have to care for the child, but also the labor productivity, we'll see later on, goes down significantly. The longer term consequence, here we see it over here. The adults that grow out of the stunted children who survive are shorter. There's more obesity as a consequence of stunting. Reproductive health is worse. School performance is worse. Learning is worse. The capacity to work and the productivity is worse. This is the brain of a healthy child, and there are lots of connections. All these nerve cells are connecting with each other. This is the brain of a stunted child, and the connections are missing. That child is not capable of learning. The severe, irreversible physical and neurocognitive damage that accompanies stunted growth is a major threat to human development. And it kills people, as I mentioned before, 45%. And this is the hunger belt, the world's hunger belt from here to here. Stunting often results in delayed mental development, poor school performance, and reduced intellectual capacity. So, increased height for age z-score. Z-score is the number of standard deviations below the mean or above. By 1 standard deviation, increased the likelihood of being able to write by 5 percentage points, and 3.4% after controlling for confounders. This is the z-score for height for age between ages 2 and 5, and this is the number of years of education achieved. Okay? More height between ages 2 to 5, more years of education. This is another study of 4 rural Guatemalan villages. In these villages, at 2 years of age, the mean HAZ score was height for age z-score was less than -3, and 86% of all children were stunted. This is Guatemala, where those stunted pictures the kids were from. Adult consequences: worse score on reading and IQ tests, poorer quality partners measured by grade attainment and height, first child at younger ages, more pregnancies, more children, more likely to live in poor households as adults. Men, but not women, had lower wage rates. Why is that? Because the wage rates of the women were already so low that they couldn't pay them any less. They were paying them almost nothing, and they couldn't lower it. This is a study that I think is very important by the World Bank, just published last year. Stunting in childhood of the adults in today's labor force lowered income per person by 7% in 140 developing countries compared to no stunting. The mean reduction in income per person due to stunting in childhood of the labor force was 9% in sub-Saharan Africa, where incomes were low, and 10% in South Asia, where incomes were a little bit higher. How did they get that number? They took the current income of current workers and reduced it by the income returns to a year of education applied to the reduction in years of education from stunting, and by the returns to an increment of adult height applied to the reduction of height, and by the returns to cognitive skills applied to the reduction in cognitive skills. So basically, they decomposed the person's capacity to earn into three components: education, height, cognitive skills. And then they estimated, if you're stunted, how much does that hurt each of those? And then they added those three together. The real effects are probably much bigger than the 7% they estimated. So I'm claiming that ending chronic hunger is a major investment opportunity. What do you do to end chronic hunger? You provide food, but you also treat infections. You educate boys and girls about nutrition. You improve the quality of water, sanitation, and waste removal. You take care of people's health when they're sick. You provide income to buy food, and you improve the status of women so that they determine what happens to the food that comes into the household. How much does that cost? This is an estimate in 2015. Eradicating world hunger sustainably by 2030 would cost about $300 billion a year. That's for everything. That's average $160 a year annually for each person living in extreme poverty over the 15-year period. Well, the same World Bank people said, let's just talk about nutrition interventions and not try to solve all the world's problems. If we just do nutrition interventions, what's the amount that we get back for every dollar we spend? And they estimated that you get back $15 for each dollar you spend on a nutrition intervention. It varies from different parts of the country because of the differences in income. If you take those returns and take account of the time when the returns come in, the net rate of return is a financial concept. What's the stream of interest that it's equivalent to? And it's equivalent to a 17% internal rate of return. That is a very good return. If I could invest my money in a bond that gave me 17% return, I would do it tomorrow. That is a very good rate of return, especially if it's guaranteed by a government and by the World Bank and other international institutions. So my suggestion is, here's the hooker. The problem is the benefits don't begin for 20 years after you start this nutrition intervention, and then they go up, the benefits per capita. The costs go up first, and they stay low. Okay? So what we need is for the government to say, okay, I will take the risk, and I will take the long-term point of view. I'm going to float a hunger bond to wealthy countries and individuals. A bond. I'll use the money today. I'll feed the children. I'll get increased earnings. I will tax their earnings, and I will pay back the bonds with the increased taxes from these people's earnings. This has not yet been done, but I'm proposing that it be at least considered. Governments should sell bonds to patient public and private investors to reap the returns in adult labor force of reduced stunting in childhood. And I would argue that ending chronic hunger should not be left to markets for food. Markets serve people with money, and they are great. If you have money, I love going to the market. It's great. But one must pay to play in grain markets. A market only works for people with enough money to pay for what the market offers. It excludes people with too little money. People at the bottom of the income distribution do not satisfy the assumptions of economists when they talk about the perfect market. Poor people are just left out of the picture. So public or private social safety nets are required to assure that everyone has enough food. This is a wonderful painting in the Boston Museum of Fine Arts. It's by John Turner, and it was made in 1840. And here is a slave ship going from Africa to the New World, probably the United States. And here is a slave in chains and other slaves. And the captain of the ship wanted to lighten the ship because rough weather was coming on. So he threw the cargo overboard, these people. And Turner's point was that this is not acceptable. And eventually, most countries in the world came to agree, that markets are wonderful, but we don't include people. We can't buy and sell people in the markets. Even though today we still have 40 million slaves in the world. That's an estimate. But officially, it's banned. So the boundary of a market was moved by a moral judgment that slavery degrades people. And I suggest that we also move the boundary of markets because hunger degrades people. We have the food. It's economically irrational to let children become stunted. We're giving up productivity that would pay for the food. So we should move the boundary of the market and exclude hunger. It should not be left to the market alone. This is an example of a general perspective that I have on population problems. Population problems are very important, but if you look at them in isolation, you miss the complexity of the real world. Population interacts with the economy, with the environment, physical, chemical, biological, and with culture, with values, what we want. Thank you very, very much for your patience. That's my story.